Hello, welcome to Cyber Entering Monday. I am Tiberius. JWT, access the lab. Alright, so let's, what are we doing here? So if I load this page in the other Mozilla, so this is the one that's being proxied via Zap. I only want to see stuff that's in scope. How do you do scopes in this? Include scope, is that it? Filter. This is so annoying.
Thank you for following.
There we go. All right. So we have this GET request. So this is just getting it. So we actually need to log in. This one gave us login, I believe. Wiener Pizza. Okay, so what we're going to do, go to my account. Wiener Pizza. All right. So if I just reload this page, you'll see we're logged in. If we go back here, I'm going to sort this way so it's a bit easier to see. So what you have, when we logged in, if I go to this post request, this is the post request that logged us in. In the response, we have this session cookie set. Okay? And this is an interesting session cookie, let's say. So if I copy this session cookie, I don't know if Zap has a nice way of decoding this. I mean, I guess we could try. Encode, decode. It doesn't. All right, so what we're going to do is we're going to do something that we really shouldn't do with actual sites. Like, never do this with customer data, but because this is a lab, we can do this. We go to JWT.io. Paste it in here. So this is a JWT. Not a JWT token. Although, if I say JWT token, it's okay. It's forgivable to say that. Because the T in JWT stands for token. It's like PIN number, right? You shouldn't say PIN number, but everybody does. So this is a JWT. Or a JW token. Which is comprised of three things. It's comprised of a header, a payload, and a signature. This is the signature. They are all separated by dots, periods, and they are all base64 URL encoded. Now, what base64 URL encoding is, pretty simply, it's base64 encoding, except you remove any padding at the end. All right, so normally this might have two equal signs or one equal sign. So one way we might see that actually is if we copy this and we go into the editor. Can I paste this? All right, so if I maybe did like I don't know, add something an A to here. Right, if I add an A to that, it gets two equal signs. But you know, if this was the case, if this was the header, it would encode it like this and then just drop the two equal signs off. That's the only difference. Same thing goes for the payload and the signature. So the header basically, I mean, it's a header. It tells you how this is all sort of formatted. The main thing that you'll find in here, you may not even find a KID. Usually what you'll find is something called an ALG, which is the algorithm. In this case, it's RSA 256. What that means is that is how the signature was generated. Okay? So this is saying, hey, this signature was generated using RSA 256 with a secret key. There are a few things you could do here. A few things you could have here. You could have HS256, which is HMAC, which is kind of it's basically think like if you were doing SHA-1 or SHA-256, but you also have a key. So that's the easiest way to explain what an HMAC is. You're doing basically a hash, but you're combining the original data with a key, a secret key. So it's not encryption, but it is still a way of generating a signature that requires the secret key in order to confirm, basically. So the other thing, the KID is the key ID, which is, I mean, not, I guess not in everything, but if the system that has to validate the signature has multiple keys configured, this is just telling it, hey, this JWT used this key to sign the signature. Okay. Another thing you might find is a TYP, a type, which is usually just this JWT. However, not everybody does that because this is kind of obviously a JWT. I probably need to copy this again, don't I? Alrighty, where are we? Paste. There we go. Okay, so that's the header. The payload is the actual data you want. Okay, so in this case, the ISS stands for issue. What you'll find with JWTs is usually the keys tend to be 3 letters long. It's just a standard. There's no reason you need to do that. It's certainly not necessary, but all of the quote-unquote standard keys are 3 letters long. So ISS just means the issuer. So in this case, the issuer is Portswigger. The sub is the subject. So in this case, it's my username, Wiener. EXP, right? Clearly experience. I'm extremely experienced. No, okay, this is expiration. This is when the key expires. Okay, and then this, very specifically, it's this data, right? So it's the raw data. It's not this encoded data. It's this data here, signed with an RSA 256 algorithm using the key with the KID this, okay? And so this is why JWTs are really mostly secure, because effectively what happens, you can have data that's public, right? This is all decodable. There's nothing hidden here. Yeah? But still, you can't change it, because if you change any of this value, if you change any of this public data, if I was to, for instance, replace Wiener with admin, right, as my username, this signature wouldn't match anymore. Okay? So when the key is generated, so when we sent this login request, the key was generated, the server has a copy of the secret key, right? It generated the JWT payload. It signed it, it created the JWT using the header, the payload, and the signature, and it sends it back as a session cookie. Okay? And now, whenever it still receives, so, like, for instance, we go here, so we went to /my account, whenever we send this session token, right, it recognizes it's a JWT, it looks at how to decode it, it decodes it, well, it validates it first, makes sure that the signature's valid, and then it uses the data inside the payload to authenticate the user. Okay. Does anyone know why JWTs are preferable over just a regular session cookie, right? Because there's, like, a session cookie could exist, which just, basically says, hey, this session belongs to this user. Does anyone know particularly why JWTs are more advantageous? How would you know this is JWT just looking at it? Yeah, I mean, it's kind of obvious. So usually they begin with this EYJ, because that is the base 64 encoded this followed by, I think, a quote. So that's always there, really. And yeah, and then the dots kind of make it obvious as well. The fact that it's all base 64 encoded as well. Multi-key hash. No. The signature only uses one key. But it's possible for a server that supports JWT to have multiple keys. They're speedy. Yeah, but that's not the main advantage. You can modify portions that generate the signature. Not really. Not really what I was thinking of. Holds more data in the payload? No, actually. So this is way bigger than a regular session cookie would be. Server-side session. You're kind of on the right lines. Because it's sent to the server every time. I mean, a session token is also sent to the server at the same time. Authorization is more reliable. Again, not particularly. The reason, okay, I'll give you the reason. So there's really two types of session that you can have with HTTP. You can have stateless and stateful. Okay. So a stateful session is one where the server is basically monitoring the session. The server understands the session state at all times. All right. And a cookie with a session ID is stateful, right? Because the server has in the database the same session cookie, and that session cookie is linked to a user account, and that session cookie in the database is also linked to an expiration. All right. HTTP auth, basic auth, where you have the authentication header and the username password encoded in the request, is really bad, but it is stateless because you're sending the authorization data every single request. And likewise, a JWT is stateless. All right. There is no need, if you think about it, for the session, so for the server to track any of this, right? Because all the data that it needs to verify that this is a correct session token is in this, right? And because it's signed, it can trust the data inside it. And the data inside it also, where are we? The data inside it has the expiration time. So it doesn't even need to check the expiration time. HTTP is stateless. That is correct. HTTP is stateless. However, HTTP is... HTTP being stateless means it was practically useless when authentication came along, and people needed sites to be authenticated. So cookies were generated to make HTTP kind of stateful. All right. An HTTP request, though, is completely stateless. You're correct. All right. HTTP request, you send it, you get a response. That's it. The server just forgets about everything. However, the fact that you can have cookies in the browser that are stored, that also reference stuff on the server, means that, yeah, HTTP, even though it's stateless, with cookies, it's kind of pseudo-stateful. With JWT, it remains stateless since token isn't stored. Right, exactly. It's only stored in the browser. And yes, in key voxel, JWT can't be revoked, so you need to give it a short expiration. That is true. That is a danger with JWT. What you could do, you could also make JWT pseudo-stateful in that way, because each JWT, you could give it an ID in the payload here. And then you could, if you wanted to revoke a specific JWT, you could just store the ID in the database and say, hey, if there's ever a JWT sent here, right, that matches this ID, reject it. Okay. I'm just going to make sure that this hasn't just expired my account. Okay, good. So JWT, the web app was stored with JWT? No. Web apps don't need to store the JWT. The browser stores the JWT. If we go into here, if we go into our browser and we go into storage and we go cookies, there's
Thank
the JWT.
you for following.
This is the only place it's stored. And again, it doesn't need to be stored anywhere else, right? Because the information that's linked to the session is in the JWT. When the JWT is sent as a cookie to the web server is going to verify the signature, right, to make sure that the JWT hasn't been tampered with. Once it's verified, it knows that whatever data is in the payload came from the trusted source. All right, and so it'll check and say, okay, well, the subject is Wiener, so this JWT belongs to the user Wiener, so we log them in as Wiener. All right, and it hasn't expired yet. So this is the big advantage of JWTs. Another advantage in that sense is that you can get other sites that you trust to generate a JWT for you. Right? So this is how I think it's Authns. Oops. Is it Auths? Or Auth1? I forget which is. There's a popular there's a popular authorization platform, and I completely forgot what it's called. I don't use it, but a couple of customers do. Basically, it's like a single Auth0. That's it. Yep. Auth0. Yeah. So Auth0 kind of works this way. So it's a universal single sign-on, right? So basically, you're saying I trust Auth0 to generate JWTs for me, and then effectively you always, in a way, you can get Auth0 to do all the authentication for you, and know that it's trustworthy. All right, so the JWT signature doesn't have to be tampered with in order for it to work. We just alter the username. Well, if you alter the username, then the signature doesn't match. Remember, the signature is generated from this payload, right? And so if you change this, now the signature doesn't match, right? In theory. So this is actually where this comes across, because this is the #1 attack against JWTs. Yes, we're going to hack them now. So the main attack against JWTs, right, or the easiest attack against JWTs is this thing, unverified signature, right? And basically, just a guy kind of nailed it on the head. If you don't verify the signature, right, first, if you don't check that the signature matches the payload, you can just change the payload. And so that's what we're going to do. So actually, I'm going to go to... I'm going to copy this payload, which goes all the way to here. Honestly, how do I... Is there not just an encode decode tab? I wish there was. All right, so we're going to decode it to that. We're going to copy it to here. We're going to paste it in there. We're going to go admin, or probably administrator, to be honest. All right, and then we're going to go here. Copy this. No, we don't need to take any padding off because there was no padding. All right, if this was administrator, we would have to take away this equal sign and just copy all of this. But in this case, we were lucky. The administrator doesn't have any padding. So if we copy this, and then we go into our thing here, go back to storage, cookie. All right, so now, you know what? I'm gonna make a new file. So this is the payload that we've messed with, and this is the original cookie. So we're going to copy the entire cookie. Okay, view word wrap, please. All right, so this is the original cookie. This is our messed up token that we're going to paste in here. Okay, so that's all we've done. Oops, it shouldn't be on enough different line though. Oh, why did... Hang on a minute. Oh boy, hang on. All right, session is this thing, yes. Encode, decode, decode. I just want to make sure I'm doing this right. Okay. If this is doing what I think it's doing, I really hate that. Okay, hang on. Copy this. Oh my god. Copy? Yeah, what's Zap doing? Zap is literally putting a new line where there shouldn't be a new line. This is indefensible. This, I'm telling it, hey, can you base 64 encode, right? This string. Zap is saying this is base 64 encoding this string. It's not, because this is a new line character.
Thank you for
My
following.
god. It wouldn't wrap the string. That's the point. You shouldn't... It does it here correctly. This is actually base 64 URL encodings. This is what I need. But still, this is... Oh my god, stupid. I hate Zap. Yes, that fail is for Zap. All right, so we're going to copy this and we're going to paste it in here instead of this stupid thing. All right, so now we set this cookie. Okay, so we're going to basically delete the session cookie, paste in our new one, and then hopefully if we refresh, we are the administrator, right? Makes sense? So usually this attack doesn't work. What was our payload? Our payload was literally just, it was the same payload as before, we just changed the subject to administrator, all right? In our original one, the subject was our original username, Wiener, okay? But more importantly, this signature, right, does not match this anymore. It's not very common at all, no. I've never actually come across a site that didn't check this. However, actually no, I lie. I think I came across one a few weeks ago. Yeah, I did. Ignore me. Very rare though. That was the first time I'd come across it, actually, so that's why. This works because the web server doesn't even validate the signature. So there are two functions within when you're dealing with JWTs, right? There's basically the validate or like verify, right? Which effectively both of these will take the payload, right? So this thing, and they'll take the signature, yeah, and they will make sure that the payload, when it's signed by, right, secret key equals blah blah blah, right? So the secret key is obviously stored on the server. The validate function will take the payload and the signature. It will sign the payload using the secret key and basically do a very simple, right? Let's just do, hang on, just do some pseudocode. So if sign payload, right, with secret key equals signature, like return true, right? Otherwise, oops, what the? Otherwise, just return false. Yeah. So that's the first function, the validate function, or verify, whatever you want to call it. And then there's like the regular just like decode, right? Which basically just decodes this. I think it talks about this in the they may actually call it something different here, but let's verify and decode. Actually, there we go. I was completely right. So yeah, the decode basically just takes the payload, right, and it returns whatever this decoded payload is. Simple. And what we could probably do just to show show how this kind of works. I wonder if it does actually check the expiration. So let's just set this expiration to back in the past. So I just changed that second 6 into a 0. And then maybe this should log us out, I expect. If they've actually enabled the feature, I should actually copy this into here. Nope. Copy. Did that change? It did. Okay. That you look at the 2 turning into a W there. All right. So if I copy this, oops. Delete and paste, and then refresh. It probably should be logged out. I am. Okay, so that's the easiest way of defeating JWTs. Let's do the next way. Signature verification. So I think we probably have to log in as Wiener Peter again. All right, good. Okay. So the first thing we'll do is we'll try doing this attack again. Okay. So we're gonna go up here. I should probably, I guess, go to my account, go back to burp. Sorry, burp. Go back to zap. Oh, I need to add it as a include in the context. And you know what? We'll remove this one. Oops. Remove. Okay, there we go. Nice. Okay, sort by that. Okay, here we go. So we have our session cookie again. So I'm going to copy it all out. Okay, so we copy this. All right, we're going to go into, we're just going to go back to JWT.io. So again, it's the same thing, right? So if we do copy this out, go into this encoding, we're going to decode. Here is the base64 decoded, or URL decoded. Copy that. We put it back here and change this to administrator. Okay, so exactly the same attack as before. We're going to copy this base64 URL encoded version. We're going to paste it into here. And we're going to do the same thing. We're just going to copy it into our cookie. Storage. Delete that and paste. And then if we just make sure I did actually do that. Okay, refresh. Is this going to work? No. All right, so they fixed it. Okay. On the JWT, if there is one, what is the best way to get that? Oh, JWT key. I mean, usually it's hard coded into the web server somewhere. It's on the web server. So it's extremely difficult to find. Generally speaking, that's not. I mean, there are attacks based on the key, which we'll probably do at some point if we keep going with this JWT stuff. But generally speaking, it's yeah, it'll be difficult to find. Is there an attack where you brute force them? There is, yes. That's with the HMAC. With the RSA stuff, no. The RSA-based keys are considered unbrute forceable. Because RSA is generally speaking a pretty decently secure key. I mean, it's 256 bits usually, which is honestly very difficult to. I mean, it's infeasible to brute force, pretty much. Okay, so we haven't been able to do this, right? So we did the same thing. We changed Wiener to administrator. But it looks like they are they're verifying it, right? So they actually are what they're doing. When the server receives this JWT, it says, okay, well, hey, this JWT says the signature was generated using the RSA 256 algorithm with this key. All right, so what it does is it uses the RSA 256 algorithm with this key, so the key ID. So basically, this isn't the key, this is a key ID. So this is it looks up the key on the system based on this ID. It takes the payload, makes a signature, verifies it against here. Okay? So there is a way to defeat this. And it's because the server uses this ALG field to determine how it generates the signature, how it does that to check. And so the reason it might do that is if you, for instance, have a server which generates multiple different JWTs using different algorithms for whatever reason, okay? So it might be a legacy kind of thing. Either way. So what we can do is we can change this to an algorithm which we know how we can generate a signature of. You might think that's kind of impossible, but we look up the JWT standard. It's probably this. Search for alg. Here we go. When were JWTs invented, by the way? When does this come out? 2015. This document came out, which honestly proves that even in recent days, people don't understand security. Yes, to support use cases in which the JWT content is secured by a means other than a signature, JWTs may also be created without a signature encryption. But why? I want to go back in time to the meeting where somebody thought up this stupid use case. Like, you're literally, the whole point of JWTs is you have the signature included in the token, right? So what person in the room was like, hey, you know how we're creating a token that has its signature included in it with the way to create the signature all in the token? Yeah, what if somebody doesn't want to do that? And nobody was like, well, why would you use a JWT then? I can't think of a single use case where somebody wants to use a JWT, but not use a JWT. Ugh, it's just ridiculous. Okay, so yeah, there is an algorithm called none, which does exactly what you would expect. So what we're going to do, we're going to take the header, because this is all we need. Remember, we've already changed the payload to use administrator. And so we're going to go to decode, paste the header in here. All right, we're going to copy this. Paste it in there. We could change the algorithm to none. We could leave the KID in there. We don't need to. I'm just going to leave it in there just to make it easier. This isn't... Oh my god. Are you serious? This isn't base64 URL encoded. Why is there an equal sign? Like, the whole point of base64 URL encoding is you don't have equal signs. There's even a wiki page, I'm pretty sure. Well, this one, base64 URL. So let me just... What's the point? Yeah. This is honestly why burp, it sucks. It can't even get basic shit right. This is wrong. This is wrong. This isn't base64 encoded because it has a stupid new line in it. Yes, I know the base64 function, right, generates new lines, but the fact is that it just does that for readability reasons. That's not actually how base64 works. You should always use -W0. Like, don't make assumptions. Oh, I hate burp. I hate zap. What are we talking about? This isn't even burp. Yeah, burp doesn't do this crap. All right, so this isn't base64 URL encoded. This is, right? Everything apart from the last character. And Zap should be ashamed of itself for this. Okay, so we're going to take the header. So remember, this is the header. All right, so we're going to put it here. Okay. And we've given it an algorithm called none. which means there's no signature. So we're going to select the whole signature, and we're going to press delete. All right, we're going to leave the dot because here's the signature, right? We need to separate this. A JWT always has three things. It always has a header, always has a payload, and always has a signature. Just in this case, the header said there's no signature. So there's no signature there, right? There's 0 bytes after this dot. Okay? So we're going to copy it. We're going to put it into our cookie. Press enter, and then hopefully if I refresh, we should be logged in as admin again. Okay, we're not. Did I mess it up again? Let me just double check I got everything right. This is probably an issue, user and keyboard issue. Decode. Algorithm none. Okay, fine. Did I mess this up? Administrator. Oh, did I not encode? Oh, wait a minute. Maybe I didn't encode this properly. I'm just going to double check here. Okay, so we're going to copy all this. No, that should be right. Okay, so the other thing it might be, the cookie was set wrong? Okay, we'll try that. It might be, so there are technically different null algorithms it could be using. Oh yeah. Oh, I didn't set. You're right. I didn't set I set the domain. I'm just an idiot. Okay, now it should work. No. Oh, it did. No, it did work. I'm just on the login page. We're in the admin panel. There we go. It worked. It worked the first time. I just didn't set. What I did, I was being too quick, and I think I overwrote the domain instead of the value. Thank you, Tagora, for raiding. How was your stream? So to solve a lab, you just need to delete Carlos. Yeah, so like I said, there are technically there are ways of getting around if it doesn't support the none algorithm here. And Burp actually has a nice plugin for this. So it might not support none lowercase, but it might support a capital N there. It might support all caps. And sometimes I've seen it where you just do alternating case, right? Either that way or you do something like, sorry, there. Okay. And that's just if the developer has done something stupid, like when they're checking the algorithm, they do like if al equals none, right? Return false or something. Right? Which is obviously a dumb way of doing it. Weak signing key. We didn't open it. All right, so this is going to be brute forcing, I believe. Somebody mentioned this earlier. Okay, so we'll log in again. Wiener and pizza is not the password, apparently. Oh, I should probably load this in the actual thing there. Okay. Let's just go back and see. Here's Wiener pizza, but okay, Wiener pizza. We're going to add. Okay, so 0AC needs to be included in the context, and 0A4 doesn't. Sorry, 0A74. Okay. All right, good. All right, so we are logged in as Wiener. So let's copy the code. All right, so if we go here, we'll copy this token. I'm just going to paste it here, and we're also going to paste it into this to see how it differs. And for the first time, you see this HS256, right? This is the HMAC. This is an HMAC based on SHA-256. The H stands for HMAC, the S stands for SHA, the 256, SHA-256, okay? So effectively, and like I said, with an HMAC, we go to HMAC. All right. It's a key hashed message authentication code, right? So it is a hash, basically. Okay. And what you do...
Thank you for following.
Thank you, Stanley. Right, so you have a secret key with an HMAC, K, and basically you XOR it with a pad, you hash it, right? So you take the key, you hash it, and you pad it first, and then what do you do here? You generate a key derived from the secret key. Okay, you concatenate that with the hash of the key concatenated with the message, and then you hash all that again. All right, but yeah. So it's a complicated process, but it's all public. So the algorithm is public, right? So if you know K, if you know the secret key, or you can guess the secret key, and you also know what M is, you can generate the HMAC, okay? Because K, whatever you call this, K apostrophe, is derived from the secret key, and you know the secret key, all right? And you know all this stuff, you know how to do all this, you know how to concatenate, you know what M is. So the reason why this is dangerous, why HMACs are dangerous with JSON, is obviously the whole point of JWTs is you know the payload, right? The point is you know what M is already. Oh, what am I doing? Here we go. Okay, we know what M is. It's this. Yeah. So in order to generate a valid signature, right, we just need to know what K is, what the secret key is. And the best thing as well about JWTs is a valid signature. So a signature is included in the JWT. So we have M, we have the message that we need to create a signature for. We have a valid signature for this message. So if we just try every single key, or if we try a word list of keys with this message until we get this signature, then we know what the key is. And then we can just change this message and generate a new signature. Make sense? So I believe, is Hashcat installed on this? It is. Okay, so Hashcat does have an option for doing this. So we'll probably use Hashcat JWT. I don't think John does, otherwise I'd use John, but I think Hashcat has one. So we need the whole JWT 1650, 1600, sorry. 16,500, okay.
Thank you for following.
So if we just, I'm just going to put that here. So we're going to copy this. We're going to vim jwt.txt. Okay. Now, they did give us, for the purposes of this, they did give us this word list. Okay. So we'll do raw, and we'll just download this. All right. Okay, so we have the secrets list, we have the JWT. So if we do hashcat, I'm just going to reference this article because that seemed to be pretty good. So it did. So I think we need -A0 for the mode. 16500 was the thing, and then we do jwt.txt and then jwt.secrets. I think, maybe. Let's see what happens. So this is one way you can do it. There is also a JWT crack, I believe. Or actually, no, this one's better. Actually, there's several now. So this one written in Go. There's this one, which I've used before. This is multi-threaded. So this one you just literally give... what do you do? Yes, you give it the JWT, and you can also give it... you can give it a list of letters to use. You can give it a length, 5. I think you can give it a word list. Okay. There we go. We cracked it. How long did that take? Not long. 0 seconds. So we cracked it pretty good. So it's secret 1. Okay. So I believe then, if we... What am I doing? If we go back here... I think if we paste... Oops. No, hang on. Can we paste that in there? I just want to double check something. Yeah, okay, that did work, I think. So this site actually can handle HMAC algorithms for signing stuff. So I think, again, if you're using Burp, there are plugins for this. I don't know. Let's see if this worked. Because if not, we'd have to generate this ourselves. But I think this should work. So we're still logged in as Wiener, right? If I refresh, still logged in as Wiener. So we'll do the same thing again. We'll go to storage, select the cookie, delete that, paste this in, and then hopefully if we refresh, are we admin? Yes, we are. When we talk about JSON deserialization, what we're doing is we're taking a JSON object and converting it into what the program can interpret as an actual object, right? So yeah, JSON deserialization is very specifically taking a JSON object and converting it into, like in this instance, a C# object in memory. And so you might do something. You might have like an object, right? Let's just say we'll have a human object, right? Very basic, and this has a string name equals whatever, right? It has an integer age equals whatever 0 by default or something, yeah, something like that. And ordinarily, what you do is if you're in Java, you could serialize this, right, to a serialized string, but obviously that unlocks a bunch of different attacks where you can get code execution. So the easier way, the more secure way, is to convert this into a JSON object, and you would do something like, hey, name equals Tiberius, age equals 1337, right? And then you would have some decoder, some deserializer, which says, okay, well, this is the human object, so we're going to create a human object with the name Tiberius and the age this, right? No, these tokens aren't using any kind of object magic. All they're doing is they're basically decoding. They're doing exactly the same thing we were doing here, right? It's just decoding stuff. So what it does, the first thing it does, it decodes the header. Who won the poll, by the way? I didn't actually notice. Wasn't even paying attention. I can probably check. SSTI won. All right, we'll do some SSTI. Yes, the first thing it does, it just decodes this. Again, not deserializing, it just decodes. Basically the same thing I'm doing here. Decodes that, extracts the key ID, extracts the algorithm. Okay, then it extracts this. Keep doing the wrong one. Okay, extracts this. It uses the key ID and the algorithm to sign this, and then it just does a basic does the result equal this string, right? It is not deserialization. Deserialization very specifically taking bytes and creating an object off of those bytes. So it's not the same as encoding. You can serialize an object to a JSON string, right? You can have a JSON encoded object and then deserialize that. But the fact is, it's just a format, really. They can be vulnerable. Yes, they can technically. So I think there is one way. This thing, right? I've never come across this. This is a kind of interesting one. If I go to JWT attacks. So Portswigger often come up. I'm not sure if they actually found this in a test or if they just imagined this. My money is on they imagined it. Basically, yeah, what they were saying was, what if the KID, right? So this KID thing, where am I? Yeah, they're basically like, hey, what if this string is a file, right? I don't know how accurate that would be. I mean, again, I'm not a developer. I wouldn't expect this KID to be the name of a file on a system, right? But their argument was, what if it was a file? And then you could just replace it, right? And the cool thing about this attack, yeah, exactly, point it to dev null, right? Dev null returns nothing. So you can then create a signature based off of a key that is nothing, right? And sign it with a null, but exactly. But again, I don't know if they found this or if they just imagined it. Because I've never come across... I've tested for this, certainly. I've never come across this. It just seems kind of so weird. Basic server-side template injection. Okay, so server-side template injection. What is server-side template injection? Anybody know? We're going to load this into here. 0A3 is now the new one. Wrong browser. So it looks like... First, it looks like there's a message being reflected here. So if we change this to, unfortunately, Tiberius, we get some reflection. So obviously, I mean, the stuff you could try here, you could try and get some HTML injection, which doesn't work, right? So potentially you could get, I'm going to zoom in, potentially get some HTML injection, XSS, whatever.
Thank you for following.
Thank you for following SQL Bytes. But how does this work? So it looks like there is a div, all right? And so on the code side, what's happening is they have this message variable, right? Which they're passing into what is likely a view. So in modern day web applications, you have controllers, you have models, and you have views. The controller basically handles all the logic. The model handles the data, so the data types. And the view is how everything is formatted. And usually this is pretty secure because what it means is the controller can pass data to the view and the view can properly output that data without running into stuff like XSS. Okay. However, there can be, the way it generally works is so for instance that the variable in the URL was message. So what you might have is you might have something like message here, all right, in the view. Okay, and then in the controller, when you do something like render, let's just, what page is this actually? Whoops. This is the index page. So you might have a function that renders index.html, right? So this, or actually let's do index.tpl, right? So template files. So this might be in index.tpl, right? So obviously we have some HTML here, we have some HTML here, but specifically there is a div with this message in it, okay? And you render index.tpl, and you set message equals like args.url.message, right? Something like that, okay? This is pseudocode. This is not real, okay? I'm just trying to explain. The controller basically will say, hey, in the view, in the index.tpl view, if there is ever a variable used called message, it is equal to the value of the message parameter in the URL, right? So it's passing this specific value. How often do you use templates like that? It's very often, very, very common these days. This is almost a default for how everything works. If you do this correctly, this is fine, right? Where it's not fine is if you directly, in fact, why don't I just, it's going to open there, isn't it? No, I don't want to open there. All right. Collapse all sections of my course. SSTI, where is SSTI section? Can I pull this across here? Is that good? All right. You're getting free content from a paid course upcoming. So that's how templates are used correctly. This is how they may not be used correctly. This is just an example in PHP using Twig. No, so yeah, this is the correct way of doing it. So you can just render it directly like this. This is the incorrect way of doing it, where you can effectively tell it to render a string, and then you, instead of using these template variables, you can just pass in the variable, right? And so that's probably what might be happening in this instance. So what we can do is we can try some various things. So there is a kind of a nice fuzzing string that we can try and use to generate some errors. So what I'm just going to do, I'm going to put the word fuzz, and then I'm going to paste that, or not, because it didn't like that. All right. Okay. I mean, I guess we have to use intruder then. Not intruder, sorry. We have to fuzz it. Fuzz. Alright, we're going to fuzz this. We're going to add strings. Alright. I'm going to add all of these strings. And we're going to use a processor. We're going to URL encode all of these. Good, okay. Right. And I guess, yeah, that's... We'll see what happens. We'll start the fuzzer. I guess we have to go down all of these now, which is kind of annoying. So you'll see, we have our first payload was this $, curly brace, 7 times 7, curly brace, which when it's rendered properly will result in the number 49. So generally speaking, this is how we do these kind of things. We scroll down until we see something that isn't expected. There we go, 49. Okay. So I have a bunch of these payloads. I'll actually paste them in here. All right. So all of these payloads, if they result in a 49, you know that it's worked. Basically, the payload has been used, and it's been passed as a template variable. Okay, these last three are kind of weird. So these are basically, this one is an error causing one. So it's basically trying to use a tag called no such tag, which can cause errors. These two kind of similar, but they try and in some systems the self variable can be used to refer to effectively an object, pretty much. But for the most part, these are the ones you want to use. Well, those are the ones that get results. So the question is, can I get the payload that was used without it being in this encoded format? It doesn't look like it. It looks like it was... It looked like it was this one. It was an @ symbol followed by... It was this one, I think. So we can try that actually in the browser.
Thank you for following.
It wasn't that. Was it just parentheses then? Okay. How do I copy? This was the right one, yeah? Oh, no, wait a minute. This wasn't the right one. It'd help if I actually selected the correct... Okay, it was this one. Oh, right. It was this. It was that one. Which probably... Yes, okay, is going to work. Good. So, it was this one here. All right. And how we would generally do this, we would then go and I would check my handy cheat sheet, which tells me that this is Ruby. Okay, these two are actually Ruby. So this one may work as well. It's just this one without spaces. It does work. All right, so that was Ruby. So now we can look up hack tricks. Actually, yeah, we can look up hack tricks SSTI. And we can search for Ruby. Oh, it hasn't loaded yet. I don't know why Hacktrix is being so slowly. Ruby, okay. So you see, oh, Jesus. So you see these fail, right? But this one doesn't. This is what we have here. And so we can technically use system command to execute code. I don't know if that's what it wants us to do. Execute arbitrary code, then delete the morale.txt. So we can play around with this though. So what we'll do is we will use the system command and see if that works. So now what we do, instead of... do we need an equals? I don't think we do. We do, okay. So instead of this 7 times 7, we use system and then perhaps just ID. There you go. Okay. And so what was the requirement here? Delete the morale.txt from Carlos's home directory. Okay, so what we can do is we can just do something like ls/home Carlos. So we know there is a morale.txt. Okay, well, I mean, we did know that already, but so what we're going to do is just replace ls with rm morale.txt. And that should delete it, and it does. So yeah, templates are very powerful. When used properly, they're fine. But when used insecurely, they can be just terribly dangerous. Server-side template injection code context. So what is this? I mean, this tells us what template it's using. But we can probably figure it out. So I wonder if this is using a actually it's not. I'm just gonna post a comment test and see what happens. I mean, we can basically just do this and see. All right, what I'm going to do, I guess we should probably look at these requests being sent. Okay. All right, so what we're going to do is we are going to do the same thing again. We're going to paste in our lovely list of stuff. Okay. We don't get anything. Is there a login? I wonder if there is a login. Ah, it's probably a login. Okay, so we have this. Yeah, this is going to be, isn't it? So we have preferred name, submit. I'm just going to submit these and see what we get from in our still doing it. No, okay, go. Okay, so these, whoops. All right, these 3 post requests. Okay, I understand what this one is now. So remember what I was talking about before? Let's go. Yeah, here we go. With this thing, right? So you've got a message variable, right? You can actually post objects. So if this was like a message object, right? So let's just say message. So this is in the controller, right? So controller. This was like a new message test, and then it had something like author equals Tiberius, right? Yep. Imagine this was happening, and then we set message equal to message, right? So the message variable being passed to the template is this message object. So what you can do, obviously, with a message object, let's just actually say this was content, right? Equals test. So you can do message equals message.content, right? And that's going to extract the content of the message. You could also do message.author. Okay. So in this example, what you see here, this user.name, clearly what they're doing is they're taking the user.name and they're just putting it inside one of these, right? So they're just pasting it in here, right? Which is stupid because then you can literally just do, if you send, right? So user.name, and they do that, right? Now we're escaped out of this, yeah? And then if we start a new one and do like 7 times 7 or something, we can see what that does. So what we'll do is we'll resend this post request. I don't think the cross-out request forgery thing does not change. So we can just do this. Oops. If I just paste this in here, I think. If we send that, and then if we refresh the page, I'll just go to my account. Did it actually work or not? Response. It didn't, but it might only get displayed on the blog, maybe. I mean, let's just post a blog post and see what happens. There we go. There's the 49. Right there. Okay? So what's happened is we have an instance like this, right? And what we've injected is this. So you get the username followed by whatever 7 times 7 is, which is 49. Notice there's no space, right? Because I didn't put a space. If I wanted to do that, I could do like, let's just put a plus in here for a space, right? Send that, and if I make an, what if I refresh, does it work? It does. All right, there's the space. Okay. So we can determine it was using basically this style of tags. All right, so if we look that up in my cheat sheet, well, I've got a couple. I got ginger, pebble, and twig. This one actually said it's a different one, so I probably need to add that to my list. Tornado. I'm gonna have to add that. So we could do. I mean, so what we could probably do is send something like maybe send self. And refresh this. There we go. All right, so global name self is not defined. This is why I use self. Sometimes self is not defined like this. Sometimes self actually gives you data. However, in this case, it doesn't matter. We got the name of the package, right? Tornado. So even though we were actually told it, this is how you would discover it. So tornado template. And now what we can do is just exactly what we did before, right? Go back to Hacktricks, search for tornado. Okay, and it looks like you can just do this, I guess. What did it actually want us to do, though? Let's probably see what it wants us to do. Execute arbitrary code. Okay, that's basically the same thing. If there are any questions about this, by the way, please ask. Why didn't it copy? Oh, it didn't copy because I hate this about Hacktricks now. You can't copy stuff. You have to click this, and then you have to paste it, and then you have to select what you want. I'm going to do ID. I prefer ID over who am I. It gives more data. All right. Yeah, I'll do a plus there. So the plus is just a space. Hopefully then this will work. Let's refresh. The error should go away because we replaced our username again. Here we go, yeah. How did I escape it? So in this case, we noticed that when we were setting this, our preferred name, if I inspect this, I'm not sure if you can see that, but the values that we're actually submitting are user.name, user.firstname, user.nickname, which screams out, hey, there's a user object, right? And we're passing this exact value. So they have some kind of weird thing where, like, maybe remember how I said there was a way to render templates from strings, right? So instead of rendering it using a template file, you can actually render it using a string, right? And you can say user equals user. And in this instance, what they were doing was they were just doing this. So they were like concatenating. Actually, it's probably just like name, right? Yeah, actually. Oops. Let's go change name equals name. And so whatever we set our preferred name to, right? So let's say we set it to user.firstname. Right, so in the database, there's a field which says, hey, this user wants to use user.firstname. And so it pulls that in, it sets name equal to user.firstname, where user here is some object up here, right? So it's basically a user object which says, hey, my name is Tiberius, right? This is all happening during authorization, right? This is effectively our cookies being passed to the server. It's saying, okay, the cookie matches the cookie for this user. This user has a user object here, and the user object has a value of first name. And that's what's being passed here, right? But the fact is, because we're being injected here inside these curly braces, we can put whatever we want in here, right? We can set name to whatever we want. Yeah? Does that make sense? And in this case, we just set it to... so firstly, we need to end it, right? Because we could technically just put one thing in here, but if we just want to put os.system.id, right, we could try that. Yeah. So we could just inject basically this os.system.id, right? Yeah. Oops. Okay. That's what am I doing? I need to do that now. Yeah. Okay, that's valid, but the problem is I think this is going to fail because you need to import OS. So even if I send this and refresh, I need to refresh this thing. I think this is going to fail because, yeah, OS is not defined. So we need to import OS, but the problem is you can't import OS in the same... You can't import OS here, right? So what we need to do first is we need to actually end the thing we're injecting into, and then start a new one and do whatever we want with that. So can I go back to... Yeah. So in this case, what we're doing, we're using the same user.name that they presented for us, but then we're just ending the tag, opening a new tag. This is a special tag for doing imports, right? We're putting that in there, and then we're creating our own new tag here. And actually, I think I don't even need those two because there should be a dangling pair because I ended this one early. So I think this should actually work as well. So I resend that. Yeah, stream VODs are available. Also, if you're still in chat, Bonzo1DOS is editing them. Yeah, so here you go. Stream VODs are always available after the stream. I think they're available for like 60 days, but Bonzo is steadily uploading them to YouTube, which is great. There is a YouTube. And he edits them as well. Okay, so we do need to do something with this, right? We need to delete some kind of file. Delete the morale.txt. So all we need to do here, because we still have os.system, we can just do remove home Carlos morale.txt. Send. And then if we refresh the page again, should execute it, and yes, it deleted it. So that's more of like an injection. That's like a template injection properly. There's like two types of SSTI. There's the SSTI where you can actually just pass raw tags in. And there's the one where you're injecting already into a tag. And so the only real difference is with the first one where you're injecting directly into a template, you don't need to mess around with the ending stuff, right? So you could just do something like that, right? As we saw before, right? But if you're injecting inside a tag, that's not going to work, and we can probably actually even show that. So if I decided to do 7 times 7 like that, right? Refresh this page. Oh yeah, it will actually work. Of course it will actually, yeah, sorry. Funnily enough, that will work because, of course, it's just surrounding it by curly braces, and it's so in this case, if we put our 7 times 7 here, right, So even though this looks weird as crap, because templates will see that string there, right? And they will then edit that. They will resolve that to 49. And at that point, they won't do anything with this. So that will just be treated as literals. Trying to figure out if you want to be a dev or go into cybersecurity. Cybersecurity, much more fun. Yeah, so that's why that happens. Thinking about it, it made perfect sense why it would happen, but I'm not sure that there is a context where it wouldn't. Where should I start? Get yourself a Try Hack Me account. They're free. Also, Hack the Box. There's free Hack the Box accounts as well. Try Hack Me has a bunch of beginner stuff that you can go through. You should probably watch streams like this. You can also... Is there like a stream? I think I have a streams command. Maybe? If I don't have a streams command, let me get you the link. infosecstreams.com will show you people in InfoSec who are streaming right now. There's a bunch of people who recommend. Most of them stream quite regular. Al Hazred will probably be streaming tomorrow. Let me shout out him actually. Okay. Go give him a follow. He streams Tuesdays as well for new stuff. So if you've got time for that, definitely go watch it. Why does it print the curly brackets? So it does that, I assume, and I don't know this for sure, but it probably does a once over pass, right? So it will read along until it finds something it recognizes as a tag. Now, even though these are the start of a tag, the next one isn't. All right. So if it sees 3 in a row, it's going to ignore. It's going to say, okay, that's clearly not a tag. Move to the next one. So there's 2, but there's a third there. So this isn't the beginning of a tag. But when it gets to here, it sees 2, and then it sees like something that would go into tag, right? And then it sees 2 closing. Oops. And so what it does is say, okay, well, that's clearly a tag. So we're going to resolve that to 49. And after it's resolved that, well, at this point, it's reading this. Okay? And this is an ending tag, so it doesn't care about that. So it's not doing it recursively.
Gratitude dispensed.
If it did it recursively, yeah, it would go over this again. It would say, hey, this is 49, and it would just literally replace that with 49. But because it's not recursive, and because it effectively reads one character at a time and just disregards everything that's not a tag, it's just going to replace that. Okay, so using documentation. Okay, we'll try this. Okay, we're going to copy this. Okay, so I'm going to add 0A7. Include it in the content and delete this one. Okay. Identify template engine, use the documentation to work out how to execute arbitrary code. Okay, so pretty much the same thing as before. This may just be slightly more challenging. Okay, paste that in. Copy that. Okay, ID equals content manager. So I don't know if that's supposed to be something. I mean, let's just keep viewing details, see if we can find anything that looks... Oh, edit template. Well, interesting. All right, let's just delete everything then. Okay, so we're going to go back to our list of cheats and paste everything in. We'll just do preview, I guess. Or not. I'm just going to add a test at the start and a test at the end. Okay, so let's just, I guess we'll do it one by one. Maybe that's how they want us to do it. All right, so do that one, and then we'll just do 7 by 7 like that. Okay, that was it. Okay, so just a $sign 7 by 7, which according to my cheat sheet is either expression language, free marker, groovy, or Mako. So what we'll do is go to hat tricks again. So there is a. Hang on. Oh yeah, detecting errors. So we could do errors, I guess. You know what? Let's do some errors. This is another way of getting detections. Now we've identified the format. For instance, you can do something like, okay, so we could try just doing an empty tag. That does nothing. We could try doing divide by 0. That worked. Remember what I said was free marker? There we go. Now we know it's free marker. All right, so now we can go down to free marker. Okay. It looks like it's suggesting this one might work, so we can try that. Oh, I've got to copy them all, haven't I? So I'm going to paste that. All right, so we're going to just copy this one. And paste it in here. Oops. Preview. Hooray! It was easy. Okay, what do we need to actually do? Delete morale from Carlos's directory. Basically, it's the same thing. We're just abusing Carlos here. All right, I'm gonna remove. I'm typing so slow because I can only type with one hand for the next 11 seconds. All right, remove Carlos.morale. Solved. That is actually a nice way of showing how you can identify by doing errors, which is another thing I actually do go over in my course. So another way you could, so there's 3 main ways. So the first one is obviously doing an empty thing, which didn't work. Next one was doing a divide by 0, which obviously might work. The other way would be doing a non-existent tag. That works as well. Lovely. So the following has evaluated to null or missing. Okay, so that's the 3 main ways of figuring out once you've identified, like, because the thing is, with a bunch of these, you'll start to see, like, if I search for this, right? I'm gonna go down. So Java Basic Injection uses this. FreeMarker uses it. ThymeLeaf uses it. A lot of Java ones use this one. Twig uses it. Oh no, sorry, Twig doesn't use it. What am I talking about? So hang on, does this one use it? Yes. Right, so Twig doesn't use it. I don't know why they've done this, but Handlebars doesn't. Ruby doesn't. Tornado doesn't. It's a bunch of like ones that don't. I guess this is interesting for like if you suspect it's Ginger, you can do that and get an error. You can get that and that. Foobar evaluates to nothing, etc. But yeah, there's a bunch of common ones. So even like a single or double curly braces surrounded by one is kind of popular. So not in free marker, but right. So Twig uses doubles. Nunchucks uses doubles. This is Node. So that's Twig and Node. Sorry, PHP and Node. So 2 different things. I think that was it, right? Tornado uses it. Python. Actually, yeah. So there you go. 3 different languages using the same kind of syntax. Self would work. Self would probably work because there's nothing defined as self. Yeah. But if it's Java, this might work. No, it doesn't. Okay, on the stream of my socials, please follow me on Twitter, join my Discord server, subscribe to the YouTube channel, and of course follow me on Twitch if you haven't already followed. Other than that, I hope everybody has a great